The building block of analog value processing for PLC may consist of input and output processes, analog input module, analog output module, and the PLC CPU. The analog input module and the analog output module is basically the signal module. The input and the output processes, okay, observe the arrow. For the input processes is the information sending into the CPU, okay, meaning to say the sensor, which is the transmitter, is connected to the analog input module, and the analog input module will convert or will translate that particular information, analog information, into digital format, sent to the CPU. Meanwhile, for analog output connection to the output process, the information is coming from the CPU, then translated or converted using digital to analog converter, okay, and then it sends information, or it sends the right signal, or sends the analog signal to analog actuator. So sensor and transducer is the example of transmitter. So transmitter can be pressure, temperature, flow, speed, pH value, viscosity, and etc. Okay, as I mentioned before, there are minimum 4 important physical quantities, which are pressure, temperature, flow, and level. Okay, that are 4 physical quantities that we always deal with in a process control. So that particular transmitter is connected to the analog input signal module, or we always call it as the AI signal module. Okay, and this AI signal module must convert into the digital format first, because the analog signal is in term of voltage or current. So it can be 500 millivolt, 1 volt, plus minus 5 volt, plus minus 10 volt, plus minus 20 milliamp, and then one of the most popular is 4 to 20 milliamp. So this is in form of analog signal. So this analog signal must be converted into the digital format, so that after the digital format, the CPU can work with the digital format. So in terms of the digital format, the ADC will convert, current or voltage into digital format, digital unit. So digital unit or digital representation, which can be decimal number, it can be a binary number. Okay. Meanwhile, on the other hand, if we look on the digital output module, which is analog output signal module. So the analog output signal module, the information come from the PLC CPU. Then before it go to the analog actuator, it must be converted using, the information must be converted using a digital to analog converter. So here, the information is converted from a digital unit, which can be decimal number or binary number in terms of, to the current or voltage. Okay, so this current and voltage will then drive the analog actuator. So the analog actuator can be control valve, motor, pump, solid state relay, heater, and so on. So terminology used in a previous building block. So sensors Sensors which respond, a device which respond to changes in the quantity to be measured. So as I mentioned earlier, sensors is always measured quantities. We are more interested in four main quantities, which is temperature, level, pressure, and flow. So transducer, it functions to convert sensors measurement into standard analog signal. So sensor measure physical quantities. So sensor measures engineering unit. The transducer, the function of the transducer to convert that particular physical quantities, which is in engineering unit, into standard analog signal, which is in term of current or voltage. So this particular conversion is done in ADC. So what is ADC? So ADC is analog to digital converter. Before these analog values can be processed in the CPU, they must be converted in digital form. So before this analog value can be further manipulated in the PLC CPU, so these analog values must be translated in digital form. So the digital form can be in terms of decimal unit, whereby the decimal unit represent the binary number, whereby this information or this unit carry analog information. Okay, so we also have the result memory. So result memory is the result of the conversion is stored in the result memory and remain until that is overwritten by a new value. So result memory is for input. So the result memory is stored in word format. Okay, PIW is I is always stand for input, W is stand for words. So IW stand for word input or input word. Okay, we also have the result memory for output. So we have here the QW. So QW is output memory in word format. Okay, so analog output, then we have analog output. So analog output, write the analog values the user program calculated to an analog output module, where a DAC, which is digital to analog converter, convert them into analog signal. So analog output is here, analog output. So before the analog output is sent to the analog actuator, so DAC, which is the digital to analog converter, is used to convert that decimal unit into analog signal. Okay, so DAC, the function of DAC is, or the function of the function of DAC is to convert the analog information this is in terms of decimal number or decimal unit to analog signal. So what is analog signal? So analog signal, you are always interested with current or voltage, whereby the current and voltage will drive analog actuator. Okay, so analog actuator is the standard signal, such as analog actuators is device or instrument like a control valve, heater, variable drive, and so on. So this particular instrument is driven by standard signal, such as plus minus 10 volt or 4 to 20 milliamp. So more on the principle of analog value processing. So analog signal are brought to a PLC from sensors through analog to digital converter interface, which is the ADC. Analog output signal are produced by PLC through digital to analog converter interface, which is DAC. All analog signal are connected to PLC through standard I/O modules, which incorporate ADC and DAC signal conditioning, scaling, and electronic isolation. A little bit on fundamental of ADC. Assume that we have a pressure process on a pressure vessel. Okay. Pressure transmitter is installed on the vessel to monitor or measure the vessel pressure. Okay, this pressure transmitter is connected to AI signal module. Okay, this is pressure transmitter is connected to the AI signal module. Please take note that this pressure transmitter, or we call it as a pressure sensor, is a transducer in a single unit. So this unit is, we call it as a PT, is a pressure transmitter, and the pressure sensor built in with the transducer in one single unit. Okay, the pressure measurement or the analog values of the pressure is called process variable. Okay, so the pressure measurement, okay, the pressure transmitter measure the pressure inside the vessel, and this measurement we call as the process variable, or short form we call as a PV. Of course, the engineering unit for pressure is always in bar or in Pascal. PLC does not understand this engineering unit. Okay, so the pressure transmitter provide the engineering unit in terms of bar or Pascal. Okay, whereby this engineering unit need to be translated into electrical signal, which is the current or voltage. So a transducer, which is built inside this transmitter, is used to convert the variation of the pressure into the electrical signal. So for current, it will convert to 0 to 20 milliamp or 4 to 20 milliamp. Okay, so the conversion of the transducer for current is always 0 to 20 milliamp or 4 to 20 milliamp. And for voltage, it convert in range of minus 10 volt to 10 volt or 0 volt to 10 volt. Okay, on the perspective of the PLC, so the ADC is built in the AI signal module. Okay, whereby this embedded system is then translate the electrical signal, which is the current over the voltage, into the decimal number or the decimal unit. Okay, for Siemens AI signal module, the most popular signal module is 16-bit ADC. So for Siemens, it is 16-bit ADC conversion operation. Okay, so for 16-bit ADC conversion operation, we are more interested on the resolution of the ADC. So how can we determine the resolution? So the resolution for 16-bit ADC is determined by 2 to the power of 16 minus 1, which is 65,535 resolution. or we call it, or we can say steps. Okay, so what does the resolution mean? So resolution mean, in order to achieve the values between from 0 milliamp to 20 milliamp, it requires 65,535 steps. Okay, so each step is equivalent to 20 milliamp divided by 65,535. So in general, ADC, or analog to digital converter, can be classified based on its resolution. There are 8-bit resolution, 10-bit resolution, 12-bit resolution, 16-bit resolution, or even 24-bit resolution. The higher number of resolution, the smaller step size and larger number of steps, vice versa. So want to bring you more visualization on ADC, for especially for 8, 10, 12, 16, or even 24 bits. So for 8-bit resolution, so assume that we have between 0 milliamp to 20 milliamp. So it is 2 to the power of 8 minus 1, so we have 255 steps. For 10-bit, so we have 1023 steps. For 12-bit, we have 4095 steps. Okay. For 16-bit, we have 65,535 steps. And lastly, for 24 bits, we should have 2 to the power of 24 minus 1 steps.